So in this video we are going to discuss about the dehydration process, and the most common, that is the absorption dehydration process, in which we will discuss about the types of the dehydration process, and then absorption process, then the solvent used in the absorption process, and then glycol dehydration and their detailed description. So as far as the dehydration is concerned, means the removal of the water from the natural gas, that can be possible by several processes. For example, number one is the liquid desiccant, that is the absorption process. Number two is the solid desiccant, that is the adsorption process. Then we can go for the expansion refrigeration method. We can also use the calcium carbide method for the dehydration, and then we can also use the membrane technology for the removal of the water from the natural gas. So this is a brief list of the different types of the processes used for the removal of the natural water from the natural gas. Now come to the first one, a very common one, that is the absorption process. So absorption dehydration means it involves the liquid desiccant. We have to use the solvent to remove the water vapor from the natural gas. That is the basic thing. Now the liquid, or you can say the solvent that we need to have, what should be the properties they have. So the liquid that is most desirable to use for commercial dehydration process should have the following properties. For example, it should have very high absorption efficiency with respect to the water, and the second is the easy and economic regeneration, so that we can use again and again. And the third one is the non-corrosive and non-toxic. So non-corrosive, so that we can avoid the corrosion in the different parts and different columns of the natural gas, and non-toxic to avoid the basically the toxicity or the use application point of view in the domestic purposes. Then also the solvent should have the no operational problems when used in a high concentration. So that's why we have to know about it. And also the no interaction with the hydrocarbon portion of the gas, and no contamination by the acid gases. Otherwise what will happen, they will consume more and more amount of the solvent if they are interacting with the hydrocarbons, and even that is also possible to remove the hydrocarbons instead of water. So these are the few properties that is required for an ideal solvent used in the absorption dehydration process. So the solvent that are normally used in the absorption process is the glycols. So in the family of glycols, we have different types of the glycol. For example, the first one, that is the ethylene glycol. The second one is the diethylene glycol, DEG, and the third one is the triethylene glycol, TEG, and the tetraethylene glycol, that is the T4EG. These are the come to the closest to satisfy these criteria to varying degrees. So they are basically almost satisfying the criteria, the you can say the requirement for any solvent, that the property should they have. So in fact the glycol family have the very good act as a very good solvent for the absorption and the removal of the water from the natural gas. So if you look about the advantages of the glycol dehydration processes over the other processes, for example over the solid desiccant and the adsorption processes, so the first advantage is the lower installed cost. The solid desiccant plant cost 50% more at 10 mm SCFD and 30% more at the 50 mm SCFD. So you can say that the absorption have a lower installation cost as compared to the adsorption process, that is the solid desiccant process. The second is the lower pressure drop in the column. So about 5 to 10 psi is the pressure drop in the absorption, whereas in the solid one desiccant they are 10 to 15 psi for the dry desiccant units. So the third advantage of glycol dehydration is continuous rather than batch, as in we know that in the solid desiccant, that is the batch process, we have to remove and we have to unsaturate the one bed while in continuation with the other bed. But in the glycol dehydration, this is a continuous process in a single column. And then glycol makeup is easily accomplished. So recharging the solid desiccant, that is the adsorption tower, is time consuming and sometimes require the interaction of the gas cells. But in the case of the absorption process, it's very easy to make up the glycol requirement. And the fifth one is the glycol units require less regeneration heat per pound of water removed, thus lowering the utility cost also. So this is also one benefit. And the next one is the advantage, the glycol system will operate in the presence of the material that would foul solid desiccant if they are using it. So sometimes there are some materials that is available in the natural gas that are very detrimental to the solid desiccant, but in the glycol system you can go for the operational in the absorption process, because there is no impact on the you can say in the with the solvent. So these are the advantages of the glycol. Now come to the disadvantages. Let us look about the disadvantages. The first disadvantage is water dew point. Below -25 degree it requires the stripping gas and a shawl column. So that is a special type of column. So if you are going for the depression at very low temperature, for that thing you need the stripping gas and this special type of column. Otherwise, if you are doing in the normal one, we don't need any type of such column. The second one is the glycol is susceptible to contamination. It means that there are high chance that glycol is contaminated with the other available material in the natural gas. The third one is the glycol is corrosive when contaminated or decomposed. So when it is contaminated, basically available with the acid gases, so there are chances for the corrosivity with respect to the solid desiccant. So this is about the disadvantages. So in brief about different types of the glycols. Of all the glycol, almost all the plant uses the triethylene glycol because of the lower vapor losses and better dew point depression. So out of all these that we have discussed about earlier, we have given the name that ethylene glycol and diethylene glycol and triethylene glycol and tetraethylene glycol. Out of all these 4 different type of glycols, the triethylene glycol is one of the very famous, and almost every plant are using this one because of the lower vapor loss and a better dew point depression. That is the 2 reasons why we are thinking about it. So if you see about the glycols, ethylene glycol, I have given the table, diethylene glycol and triethylene glycol. There are comparison between the physical and chemical properties of these 3 glycols, and we can, with the help of that properties, we can also find out some other relationship. For example, that first one is the molecular weight. So obviously the glycol have the lowest molecular weight as compared to the triethylene glycol. So in fact the molecular weight also helps about, because number of moles is the is the mass upon molecular weight. So if the molecular weight is lower, so the number of moles will be increasing for the same mass. So you can say is mass is equal to number of moles multiplied by the molecular weight. So more mass for the more molecular weight, higher molecular weight. So basically the more amount is required for that one. So molecular weight helps you to find out the material balance calculation. Then the next one is specific gravity. So specific gravity is very close to almost all these 3 have a very similar type of specific gravity, 1.11 and 1.12. It means that it is slightly higher than the gravity of the water. The next one is specific weight. Specific weight is also a very close, 9.2, 9.3 and 9.3. And as far as the boiling point is concerned, this is also important one. So this is 387 degree Fahrenheit, 474 degree and 550 degree Fahrenheit. This is very useful because there are huge losses because of the evaporation. So evaporation means the property that is related with the boiling points. If you look about all these 3 one, so this one is the lowest one. So it means that it will be vaporized more easily as compared to the diethylene and triethylene glycol. What it means that the vaporization losses is more in the ethylene glycol as compared to diethylene glycol, and diethylene glycol have more as compared to the triethylene glycol. So there is a very less vapor losses in the triethylene glycol as compared to diethylene and ethylene glycol. So this boiling point is one of the very important property that tells about the losses in terms of the vapor. Then freezing point 9.1, 18 and 24 degree Fahrenheit. So that is the reason why we cannot go very much low temperature. So the surface tension at 77 degree Fahrenheit is given 47, 44 and 45 very close values. Heat of vaporization is given as 364, 232 and 174 here also, because we need to vaporize it. So for that thing, if you look here, the ethylene glycol have the highest heat of vaporization, whereas the triethylene glycol have the lowest heat of vaporization. So these are the few properties that are basically useful for the designing and development of the adsorption processes. So this is a typical diagram, typical flow sheet for the absorption process. We are using the triethylene glycol here, So it's a very simple diagram, so we can discuss it. This is again basically this diagram is given in the book, in the natural gas book. So both are almost same. The basic units are same, only the descriptions are different in these two cases. So we can discuss one by one. For example, the first thing that is required here is to understand the first equipment, that is a scrubber. So what is the use of a scrubber? Basically, the scrubber is used to remove any liquid, water or hydrocarbon or sand, drilling mud or any solid material. So what it means that from natural gas we can remove any type of the liquid and any type of the solid material. So we can assure that after the scrubbing only the vapor phase, only the natural gas along with the water vapor is present and nothing else is present here. So that is the picture, that is the purpose of the scrubber here. So these impurities must be thoroughly removed, because they may lead to foaming and flooding and poor efficiency and higher glycol losses and maintenance problems in the glycol and gas contactor. So these are the few problems if you are not sincere about the removal of all these liquids and the solid material from the natural gas. So a mist eliminator is also provided at the scrubber outlet to ensure the good gas cleaning. So we know that about the mist eliminator is basically useful for the removal of the very small droplets of the liquid from the natural gas. So we can say that after leaving the scrubber unit, the natural gas is almost free from the liquids as well as the solids. So we have only the vapor, the gas of natural air along with the water present, that one. So if you look here, so that you can say that is the inlet scrubber where we can remove. This is the inlet natural gas. So we can remove all these impurities, and this is the natural gas without the liquid and without the solid. So and the next one is the absorber. Is just like a column, just like a distillation column. It has several trays. So the clean gas is sent upward through the absorber, counter current to the flow of gas. So one way the gas is going in the upward direction and the liquid is coming, that is a solid is coming from the top to bottom. So this is the counter current interaction between the solvent, that is a glycol, and the gas. The absorber consists of several trays that is act as equilibrium separation stages where the water vapor from the gas is absorbed by the glycol. So this is basically what the absorption process is going on. So this is the data basically. Usually the glycol absorbs 1 standard cubic feet per gallon at 1000 psi absorber pressure. So if you put the pressure at this one, so the tentative value is the 1 standard cubic feet of the gas per gallon of the water. That is the absorbed value of the water from the natural gas. So and the next step is the gas and glycol heat exchangers. So the dry gas from the top of the absorber is sent through a mist eliminator to a gas glycol heat exchanger where the gas cools down and the hot regenerated glycols before it enters to the contractor. So if you look here, this diagram, after going through it, so we have to cool down this because it's a high temperature. You know, the solvent is, this is solvent and this is a natural gas. So both are interacted here. So now this is a dry natural gas, means dry means without water. This is a cool down basically. This is glycol cooler where we have taken the heat exchangers, and then this is the natural gas. It is now used for some other purposes. In fact, the story of the natural gas or the cycle of the natural gas is completed. Here we have the dried, means the natural gas without the water. Now, and the remaining portion that is showing here is basically the portion where we have to remove the water from the glycol. That is the glycol cycle. So this remaining cycle is explaining the glycol cycle. In fact, if you see here, this is the same thing here also. So the remaining cycle, this is a little separator, the scrubber, this is the absorber, and after the absorber, this is the dry gas for the cells. This is all in, and the remaining cycle is the basically the glycol regeneration and the water removal. So how to understand. It's a very simple one. So what happened, we have just carry out the heat exchangers. Now it's everything is gone. So top portion is explained here. Look over the bottom portion. This is the rich glycol. Rich glycol means glycol plus water. Lean glycol means lean means without water. So that is the difference between rich glycol and lean glycol. Okay, so as far as the bottom is concerned, so if you look here, the rich glycol is taken out from the absorber, from the contactor, and then again it's sent to the some heat exchangers where the temperature of this one is more higher, means the temperature of this, if suppose it's T1 and T2, so T2 is greater than T1, we are increasing the temperature with the help of some other material that need to be cooled down. This is a very high temperature, we have to cool down this glycol, that is the lean glycol. So with the help of lean glycol, we can exchange heat from the lean glycol to the rich glycol. So this is the high temperature rich glycol. This is being sent into the streaming column where we need to remove water from glycols. So as we know that we have now good experience that the glycol have the boiling point much higher than as compared to the water. So we can say that the glycol we are recovering in the bottom section, bottom for glycols, and then the water is taken out as water vapor from the top of the column. So water is removed out here. The bottom section is the glycol. This glycol is a lean glycol that have a very high temperature, so we need to cool down this lean glycol. So this lean glycol is cooled down with the help of the incoming rich glycol, and this cooled glycol is pumped to the heat exchanger. Again we need to cool down it again. So with the help of the outgoing natural gas, we can cool it down and send into the absorber column. This is a cycle about the glycol. So this is all about the process description. We have discussed here the heat exchangers. We have discussed about the high pressure filters, glycol pump / separator. All these are basically available, that is required here, and the stripping is still that is available for the removal of the water, and how the reboiler is available here, because in the reboiler the glycol is collected. So this is all about the basically the explanation process descriptions. So the same description is also basically given here. You can, if you go closely, you can understand the things. So there are some slight changes here. For example, this flash separator is here, heat exchangers are here. So although the process is same, only 1 and 2 more units are available in this description. This is available in the book, Sanjay Kumar. So in fact the explanation is given for this one, this diagram, for this one, this process description. This is a very simple one, and this is the basically slightly complicated, and the process description is given for this one. And come to the glycol plant operational problem. So there is one problem if you are using the glycol plants, so especially for the methanol. If the methanol is injected at the wellhead for hydrate inhibitions, so they can lead to several operational problem in the glycol dehydration process. We have discussed about this one also. In the injection techniques, we can provide the methanol as the chemical for hydrate inhibitions. This is a temporary arrangement for the transportation of natural gas. So if the methanol is injected at the very starting site, that is the wellhead, what will be the problem? The first problem, methanol absorbed by the glycol along with water from the gas system increases the heat requirement in the regeneration system. So what it means that the methanol is also absorbed with the water, so that create a problem because we require more and more heat in the regeneration system for the glycol. The second problem, high methanol injection rate and carryover of slugs of liquid methanol can cause the flooding in the absorber and regeneration system. So this is also the second problem, where if the methanol concentration is very high, the methanol rate is very high, so there are chances that the methanol is converted in the liquid phases, and that can cause the flooding in the absorber and regeneration system. The third problem, aqueous methanol is corrosive to carbon steel. Means aqueous means the methanol plus water. so leading to corrosion in the reboiler and still. That is again a problem of the methanol. A methanol recovery unit is required in the water vapor outlet because methanol cannot be vented directly to the atmosphere due to the environmental concern. So that is also one problem. We need to recover the methanol from the water, from the stripper. So that is also the one concern for the methanol problem. So these are the few problems when we are using the methanol at the very starting at the wellhead level for the iodide inhibition. So this is all about the process description and absorption process. Thank you very much.